Assume two elements are to be selected from a set of 6 different elements. Just to give a tangible example of that, imagine I have a hat. And in that hat is the numbers 1 through 6. So that's what I mean by 6 different elements. Now we want to reach in and pick one out. And whichever one we pick can go in that first blank. But this is going to be an experiment with replacement. So let's say that first one was a 3. And we want to do the experiment again. Since it's with replacement, though, the 3 gets to be put back into the mix to be potentially chosen again. So on the left, we have the first pick. And on the right, we have the second pick. Now, it could just so happen that 3 gets picked again. And it will go on the next blank. And this will be the permutation with replacement. Now, how many different possibilities are there? 6 ways the first one can be chosen, 6 ways that the next one can be chosen, 36 possible distinguishable permutations. Assuming that the numbers in the hat are different. If they're not different, then it gets a little more complicated. Okay, but what do we do if we're not replacing the elements? Then there's going to be a different formula for that. So when we do replace them, the formula is n to the r, where n represents the number of different objects in the hat. R represents the number of repetitions, or the size of the arrangement, it's sometimes called. That's R. As you can see here, there's 2. So for our problem down below, notice that n is 6 and r is 2. So if we want to find the number of distinguishable permutations here, all we got to do is do 6 to the 2, and then we'll have it. But the formula for permutations with replacement is quite a bit more complicated. We still use the letters n and r, but we use a new mathematical idea too, called a factorial. That's an exclamation mark. And just to give you an example of what a factorial means, let's look at 6 factorial, which means 6 times 5 times 4 times 3 times 2 times 1. You just go down the list, subtracting 1 each time, and then multiply all those numbers. That's a factorial. We'll use that on the next page here, where we examine an experiment that's done without replacement.